Take two, snow day. A little bit of a review of theoretical yield and percent yield. So, since the first one was kind of boring, I thought I'd try my best to pick it up a bit. So, found a picture of a snowman. Didn't know if you made one while you were enjoying the snow. Some other things, maybe. Maybe you made a snowflake. Hung out, whatever. So hopefully after you've finished having fun or at some point in the day, you might have come in and said, okay, maybe I'll tackle this chemistry stuff. So here we go. This was the assignment from C-Day Night's podcast, and it was to complete the stoichiometry problem. And so how did you do? I've got the answers coming up here in just a minute. But to review, remember that the process involves following the steps for stoichiometry. In other words, writing a balanced equation, figuring out what you want to find, and following the steps of converting grams to moles, moles to moles, and then moles to grams. The mass of the product formed is called the theoretical yield. In a perfect world, this is the mass of the product, assuming that everything goes perfectly in the experiment. Your task is to figure out the percent yield, remembering that percent is always the part over the whole times 100. Going back to naming and formula writing, a little bit of a review. I'm not sure how you did, but looking at the formulas of the reactants and products, look at your subscripts. Were you able to correctly write the formulas? Did you remember that sodium and hydroxide, what the charges were? Do you remember what cobalt and nitrate charges were? Did you remember that the ions and the atoms and the metals should be balanced in a certain order, meaning metals, ions, nonmetals, oxygen, and hydrogen? So in this case, in a double displacement reaction we have here, remember that what you want to do is balance the hydroxides. There's two over here, there's only one here, that's why you needed a 2 for your balancing of your reaction. How's it going? So, here's the answer. Notice the steps. A balanced equation. How did you do? Do you have the coefficients? Do you have the subscript? The next step was going from grams to moles. Did you go from grams of sodium hydroxide, which was your given, to moles of sodium hydroxide by using the molar mass from the periodic table? Then, did you convert the moles to moles using the coefficients in the balanced equation between sodium hydroxide and what you want, which is the cobalt hydroxide? Were you able to do that to calculate the moles of cobalt hydroxide? And then finally, to calculate the mass of the product formed. This is called the theoretical yield. This amount is if the reaction goes well and perfectly and all of the sodium hydroxide that you reacts, this is the amount of cobalt hydroxide that will form. Since you're asked to calculate the percent yield, if you only obtained 4.2 grams and you were supposed to obtain 4.6 grams, then your yield is something less than perfect, but not too bad, really. That was the goal for that assignment on C-Day. Moving along then, your assignment for the weekend or for before coming to class, and actually I'd love for you to turn this in on E-Day. It would be most helpful for yourself in order to move forward on a quiz on F-Day, is to make sure that you can figure out the percent in the actual and theoretical yield for each of these problems. Notice the extent of the problems. There's a few of them in here. Take time to pause at each one of these and do the calculations necessary for each stoichiometry problem, calculating the theoretical yield and then calculating the percent yield. Some of the problems are actually shorter. You won't even have to calculate the theoretical yield because that information is given to you. Good luck, and we'll see you on F Day. But prior to that, if you can drop off your work here on E Day, see you then.